So on my screen there should be a display of an editor on the left and a preview on the right. Just have a quick confirmation. We verified this earlier, but let's just confirm that the text is readable. Zoom in a bit more. So a quick confirmation that so we can read that the text is readable at this size. If not, please message through the chat. Okay, so what are we going to talk about today? We're going to talk about rethinking iOS architecture and testing with SwiftUI, and looking at three main categories. One, programmatic and visual layouts, the essential components of SwiftUI, and the new ways that allows us to think about designing iOS applications. Then more specifically about what it means to have a declarative approach to UI design and implementation. Many echoes of React and functional reactive programming generally in the declarative UI topic. And then finally, we'll talk about testing as well. I'm particularly excited about the potential for a renewed emphasis on, or perhaps a new emphasis on testing in iOS. It very much has not been a theme for a number of reasons, but look forward to walking through one example of using both new things and previously present accessibility tools in iOS development to have a level of testing on native iOS apps that I have not typically seen. So we're going to look at programmatic and visual layouts, two primary approaches, and how SwiftUI combines the two. We're going to talk a bit as well about how to have mutating changes in views in a declarative style, looking at ViewState, object data, and environment data that Swift makes available through SwiftUI. So talk a bit about testing. I'm going to be focused primarily on UI tests, and the reason for that is it's been very difficult to test interactions with iOS apps, and so making that better, I think, opens the door to a much more testing-friendly approach to building iOS apps. Finally, recap at the end, and also share some resources. So quick run through. This is a series of screens with SwiftUI with navigation links to subsequent displays. Looking here at this first screen, we've got a header, a title, and some text content, and the navigation link here to go on to the next section. So if we look at this, we go to the what to expect view. I'm just going to use the fuzzy finder to open what to, so I'm going to open a new tab and then open what to expect. So what to expect, we have a preview of just that view. We can see the similar header, title section, and text items with spacers and a navigation link to the next screen. I'm going to walk through some high-level architectural properties of this application, and then use those to dive into a bit more detail on these core concepts. So this is a pure SwiftUI application, which means that it's only using the built-in controls with the caveat that there are a couple of custom controls that wrap text labels. So a header and a title as well. The different windows or the different views in this application are all chained together using navigation links. In the previews, we have a navigation view that is rendering the individual section and embedding an environment object. The first two screens are just static displays, just showing plain text and having each view responsible for going to the next view. If we go to this next screen, which is the layouts screen, layouts, we have a similar setup. Now, there have been multiple ways to build UIs in the past, and they're still available. with the UI kit. UI kit is not it's not going away anytime soon. For the purposes of this, we're going to talk about what do things look like in a SwiftUI first world. So we have programmatic views where we can generate views using code. In the past, we built UI views programmatically, which would involve things like instantiating a view, setting the frame, or setting the constraints, the auto layout properties, adding subviews. You have to create the subviews and add those incrementally. Programmatic layouts have been my favorite way to build iOS apps for a long time. However, with SwiftUI, we have the option to make live changes in the editor. Again, this is going to be familiar if you're already using SwiftUI. We can make changes directly in the editor, and then also switch over to the visual view and make changes there. So here we have a moment as I move this around. So I'm going through, there's a question, astute observer, that the environment object is passed everywhere. This is a bug in SwiftUI. Turns out that it is necessary so you can pass an environment object in a view hierarchy. To run the application, if you attach, you can see here, the scene delegate, which instantiates the application, sets the first view, instantiates a navigation view to contain that view, and sets an environment object. That's enough to have the environment object propagate down to the rest of the application. What it's not enough for is, and I hope this will change, but if you write UI tests that exercise all the views of the application, at some point the environment object gets lost, and the only safeguard I was able to find to enable UI tests to exercise every single screen on the app was to pass down the environment object on in every navigation link, so each view has a direct attachment to the environment object, which does go against the idea of an environment object, but that is a current bug affecting UI tests. Okay, so we've got layouts, we've got programmatic view, and what I was trying to change here was the view visually, and it looks like I can't do that. The recent change. One second. So some of this is live, but we do have fallbacks in the event of issues. Okay, so we can make visual edits to the views directly, and I will show an example of doing that on another screen. A lot of this is just a standard immutable presentation of screens. So let's look at some of the details of a declarative UI. So again, this is the general structure that we're using, and you can see here there's no changing content. Now we can add some mutation through state, and the mechanism for doing that, generally speaking, is to add a state attribute here. Question, is there a link to the GitHub repository? This is not on GitHub yet, but it will be. So say we wanted to have something change dynamically on this view. We could add a counter and instantiate it with 0. And here we might say, right, print out the value of that counter. You can see here we have a default value being presented. This value in state can be changed. So we could have say after this view gets shown, after that view appears, we could have on the main queue, we could then one second. We could add an asynchronous execution after say after 1 second. We could pass in a function to update the counter. So I'm going to add a function here to be able to update the counter. And I'm going to add an invocation of that here. So this call to update the counter requires a reference to the self in order to access this function. So we'll add that. And now we have a function that will update the counter after 1 second. So let's run this. So you can see that it changed here. We can extend this. So say if the counter is under 20, we'll simply do this same thing again. Once again, wait a second and update the counter. So we re-invoke this. The terminating case is when the counter is greater than or equal to 20 to prevent this from updating indefinitely. You can see here this live example has proceeded to run this and update the view state dynamically. It's not particularly useful, but it is we've added here is a state variable that can render ongoing changes in values. And notice we didn't have to change, we didn't have to refresh or update this. Very similar to React, the view hierarchy is computed and automatically gets recomputed when a value of a state or a mutable attribute within that drives the rendering of that view hierarchy changes. So in this case, this view gets computed. So this declarative UI view gets rendered in the screen that pointed to this with a navigation link. Inside of that body, all of these are static. They won't change. There's nothing attached to them that would cause them to change. Here, because we're referencing a state attribute, when this state attribute changes, because the view hierarchy includes a reference to that state attribute, the view hierarchy will be re-rendered and re-displayed. Very similar to React, not a virtual DOM, not exactly the same technique, but the core idea is very consistent. So if you're familiar with building component-oriented web applications, many of those ideas transfer well to this context. Okay, so this is a quick overview of some view state. Let's proceed to some of the testing ideas. And this is where, before going on to that. So there are a couple of other approaches which I have demos of in the resources screen. So we've looked at a way to make changes on these SwiftUI screens. So there's no instantiation and modification of views themselves. Those are simply declarative invocations of SwiftUI structures. Anything that changes is an input to one of those structures and is automatically computed by SwiftUI. So proceeding on to high-level sections on testing. I'm going to focus primarily on UI tests because, as I mentioned earlier, it's been difficult to test screens on iOS apps. And a big reason for that is that all the things we're just looking at on a declarative UI screen that had automatically refreshing rendering for specifically defined mutable state, all of those things are not true in a default world of view controllers in UIKit. It's been possible to recreate and build systems in a way approximating some of these ideas, but the core architecture of UIKit and view controllers relies heavily on a tight coupling between what gets shown on the screen and what is in a view controller. A view controller is both, or it encapsulates both the items to display and the mechanism by which display happens. Concretely, some things that were much more difficult, that are much more difficult in a UIKit world. We have here a couple of components that we've defined. We have a header and a title. We open up a new tab and just go to the header. The header has no state, it has no environment, it doesn't need anything to be passed into it. It's simply a plain component. And this can be previewed. We've got a preview with just the default iPhone 11 display. We can add previews and visualize how this would be rendered on different screens, but we're not defining the screen here, which means that we can extract and identify the units of composition at the visual level. So the visual units of composition can be these views that can be incorporated into various screens. So the header here and the title as well, these are isolated views that can be designed, interacted with, and previewed visually independently of running the application. And it's a huge thing, because often in the early stages of working through potential interactions, the part that is most murky is how should all of these interactions be pieced together. And some of that emerges only over the course of development, and requiring answering the question, what might a header look like, or what might an individual widget look like, requiring that question to be answered in the context of setting up a full-blown user interaction to render various screens and add interaction points, forces a premature commitment down a particular path. So that's been useful, and hope you're finding that interesting to consider and try out. Okay, so visual and programmatic changes. So of course here we can make changes in the editor. I'm just going to put this into a vertical stack, and then we add a spacer, and then add another text item. It's just visual. So we should have an updated preview here, where we can see this is just expanding to fill up the space allocated to it. Because the preview is within a screen, it'll just fill up to the screen. I'm going to get rid of that spacer, and we'll just see these things in the middle of the view. So using the visual editor, if I command click on this visual component, I can extract a subview, I can embed it in a stack, embed it in a list. I can also repeat it. So I'm going to repeat it 5 times. And then let's also embed this in a horizontal stack. So it's now put this repeating view into a visual stack, or into a horizontal stack. Not exactly what we want. So let's move that so the horizontal stack is outside of the list of views. We resume this preview. We should now see the horizontal row of these items. But now we can do some additional things. So let's add a component. So I'm going to hit this plus icon and find a circle. I'm just going to drag that directly into this view. Just put it there. You can see we have a large circle. Move it into the stack. It's a bit simpler. Let's add some padding to this. So here I am selecting the horizontal stack, and you can see in the inspector. I know it's probably very small. Double clicking on the horizontal stack in the editor, I have it selected. In the visual, in the canvas visual preview, can add padding. So let's go ahead and do that. Add padding to the left and right, to the top and to the bottom. So we can see it updating this in real time. Visual designs are not new. They've been around in Interface Builder for a long time. It used to be a separate app, then it was added to Xcode, and then a number of years ago, storyboards were added as another way to build views visually. What's different now with these tools, and iOS is not the only platform that is starting to have better tools that match the code level definition and a visual preview. But something that's different here is this was largely generated by visual interaction, and it's reasonable code. It's the code you would write if you were writing this by hand. And it's easy to make changes directly in the file. So I might change this to 3 displays. There's a seamless interaction here that was not possible before. And especially for someone who's preferred programmatic views for a long time, one of the best parts about the visual tools of SwiftUI is that they really have the code as the source of truth. And this is proper Swift, just defining a structure with a hierarchy of structures. It's not XML. It's not subject to the many challenges there. But I'll save a rant against Interface Builder for another time. So this is some example of interacting with visual views and making changes on both sides. So for the sake of getting back to simplification, the changes I've made, I'm just going to go back to a previous version, go back to what we had originally, where we simply had the standard title. I'm going to resume the preview. So we're back to the structure. It's a question about how we moved on to SwiftUI as a company and how are we handling these bugs. We're actively using SwiftUI on some new development. It was announced about a year ago. There's still certainly bugs and gaps. For new apps that are in development now and they're planning to be released over the summer, we're leaning pretty heavily on defaulting to SwiftUI for the general definition of visual components in the application. There are places where you have to fall back. We have plenty of reasons to be careful about switching over to SwiftUI on existing applications, especially with more complicated layouts. So for us, we're excited to be using it and are interested in defaulting to it. We've got some cases where that seems to be there's some types of user interactions and sequences of screens where that seems to be an ideal fit. But it is a developing situation. I expect after this summer's WWDC, although who knows what to expect in these days, expectations have certainly changed. I do expect that with SwiftUI being refined and updated, the second major version of iOS to include SwiftUI or to be developed after SwiftUI, I think will stabilize it considerably. But there are a couple of things that we'll see. Okay, so that was some talking about the views and making changes in both the visual context and the programmatic context. Testing. Throughout this, you'll see that basically every conceivable view, with the exception of spacers, has an accessibility identifier. The accessibility identifiers have been around and available for a long time, since iOS 7, or it's certainly been around for a number of versions of Xcode and of iOS. This was possible in UIKit. Last year at WWDC, Apple announced a number of improvements to accessibility and improvements that extend even into the development tools to be able to use Xcode to build applications in an accessible fashion. There's an impressive demo and description of using voice-guided commands to build full applications from last year's WWDC. Highly recommend checking out that session. There's an accessibility reason for using identifiers, but accessibility would be a whole other topic, and not one I am deeply versed in for conversation here. In addition to standard accessibility considerations, these accessibility identifiers are helpful for testing. And I think it helps to reframe the integrated UI testing of iOS apps as demonstrating accessibility of the app to an autonomous agent or to a non-human user, in this case, a test suite in the Xcode UI test tools. Okay, I'm gonna run into the visual tests. Now this is a bit ridiculous, but it is intended for to illustrate a concept. So we have a suite of UI tests that aims to exercise the entire application. It's a slow test suite because of that, and there's certainly brittleness in assuming that the app works exactly the way it does. But for the sake of basically demonstrating an idea by showing one extreme version of it, I hope it'll be useful. So we have the standard setup of launching the XCUI application, and then we inspect what's on that first screen. So on the intro screen, which if I open up this first screen of the app, it's a welcome page, or a welcome screen rather. It has a view showing some content. Each of these views has an identifier. So we can look at the header by looking for the intro.header selector, if you will, or the query to find the element matching intro.header as its identifier. And then we assert that it exists. So we look for the intro header, assert that it exists. Do the same thing for the title. Look it up based on the accessibility identifier, assert that it exists. The same thing for the company, for the presenter. So this is asserting that certain elements are accessible in the presently visible view. So we're in the application, we're viewing, this is running as a simulator. It's running through these interactions on the app and inspecting what's presently visible. So if I run, let's see if I can very briefly run one example. I'm just going to run this in the iPhone 11 Pro simulator and run the first UI test. I'm going to open up the simulator so that we have the visual reference. So it's launched the app, and then it's tapped to the next screen, went back. There's a bit of a delay with the animations and with waiting for things to time out. Okay, so it ran the app, interacted with these first screens, and finished the test. So we did that for the first screen. At the end of it, there's at the end of each screen, there is a navigation link to the next screen or the next view. And we have an identifier, basically the screen name .next for each view. So at the end of the intro screen, we go into the next screen, basically confirm that each screen on the app has the elements that we want to be there. This is not asserting anything about the content, but we'll get to one that asserts content and interactivity and changes. So making sure that we've accounted for the header, the title, the company, the presenter, and that we have a next button, that we can tap on the next button, and that we can go back. This is ensuring, as a user or as a simulated user, making sure that there are things on the screen, you can tap onto the next screen and you can go back. So if any of those parts are gone, this would trigger a build error. So that's sort of high-level UI tests. Nothing special about it except for that I've never seen, well, not never, but I found it to be very uncommon to find iOS apps out in the wild that have really any significant UI or unit testing to speak of. I hope that's changing. I hope the occasion to rethink how we're building iOS apps will lend itself well to rethinking how we test them also. So it's the first screen. We do the same thing for the what to expect screen, and you can see it's very similar. Different identifiers to identify the screen, but very much asserting that something exists, asserting that a series of UI elements is present. Once again, going to the next screen, tapping on the link, and then going back. So the first few screens are very straightforward, or they're all doing the same thing. It's a bit tedious to write out all of this. It's a lot less tedious when the execution of laying out a screen is closer to something like this style, rather than the considerably more code that would be needed for UIKit and auto layouts. So one thing I'm looking into more is how broader accessibility concepts and topics for building iOS apps that take advantage of the latest Apple tools for accessibility, how those can help mutually reinforce both the verification and ongoing testing of the app, and making the app more useful to more people. So we have a number of screens like that, the declarative UI screen, the testing screen. Most of these just have a list of views. Now, the test review screen, or the review screen, is later in the app. So you can see with this style, again, for the sake of this example, the test begins with the assumption that the app is starting from the first screen. So there are options for configuring the options that the app launches with, updating state. For the sake of this naive test suite, we're just assuming we're starting at the first page, tapping through each item, and then getting to the final screen. So third screen of the app, we have to tap through the first two, and so on. So where I want things to get, things will get a bit more interesting. So after the review screen, we have a list of resources, and this list of resources is one that's doing quite a bit more than the other parts, other screens in the app. We had an example of using ViewState to show an incrementing counter. Now we'll use state. We'll use the environment to subscribe to changes, involving both changing data and also interacting with classic UIKit notifications involving the keyboard. So as the last screen of this application, we have a list of items, and we have a toggle that's simply modifying local state in this view. The local state is a Boolean attribute defaulting to false, and we use a toggle control, and the toggle with the toggle switch automatically updates the basically inverts the value of this bound variable, which is a reference to the state attribute. It automatically toggles the value of that bound value every time it gets every time it's interacted with. So if this value is false, the toggle will be turned off. If the toggle is turned on, this value will be true. Then we go through each of these, each value in this user data object, and check to see if the toggle is selected. So basically, if we are, if there's a switch Apple resources only, and it's true, then we will show it because it has, we'll show a resource because it came from Apple. And if we're not showing only Apple resources, then we'll show it in any case. And if we simulate this, we can see here the live interactivity as we toggle this. Now this is strictly a filtering. It's functionally a filtering. So we have the state, and we're not determining how that state gets changed. We're simply binding to it. Toggle is taking care of the inverting of that value. And this check, this review of a state attribute is determining what to render. So simply toggling causes that view hierarchy to re-render. A couple of questions come in. So decoupling navigation from views. There's been a lot of debates in the iOS world about how to manage control flow in applications. Part of that is because of the difficulty of the default structure of view controllers, in which there's a natural tendency for everything to be agglomerated into a single view controller. Control flow across applications, across views. For the sake of this example, and this kind of for a series of screens where a view can identify that that navigation to the next screen, or identify when navigation should happen. I don't think embedding navigation from one view to another is as big a problem in a SwiftUI context as it tended to be in a UIKit context. But there's a lot of material. Unfortunately, we won't have time to get too much into that at this point. So we try to get to a close in showing a couple of things here. We have an environment object that contains user data. This environment object is simply an observable object that publishes a resources array and has a notes dictionary that has a string of text with a note for a resource. This resource data is simply in a data file that uses the boilerplate decodable protocol to load in a set of JSON values into a resource struct. So the resources JSON is simply a short list of JSON records. It has an ID, a title, URL, and a source. All of these are strings for the sake of simplified demonstration. If I go here to the resource, it's a basic struct that has attributes, conforms to hashable, codable, identifiable for lists, codable and hashable for the encoding and decoding that we have. So we have this view, and we're passing in user data that has a list of resources. And here in this resource list, we have that toggle, and then for each resource, we have a resource link. This resource link takes in a resource and returns a view. It builds a navigation link with the destination of this resource detail view. It passes in the resource, it passes in notes or a default value for the notes for that resource, and then passes in a function to update the notes. And this function, update notes, is the return value of a function to make an update notes function. So you pass in a resource, get back a function that receives a string and returns void. So for each resource, basically going through each resource, we build the resource link. The resource link has the navigation detail and includes a function that's able to update user data notes for that resource. I'm not saying this is the way to do it. This is a way to demonstrate flow of environment objects and data without requiring the leaf node or the destination view to know anything about state or environment. So if we look here at the resource detail, in the resource detail, resource detail will be best as a preview on actual device. But if we go into the resource detail, we have a keyboard responsive view that renders this stack. It has the header, the title, has all of the standard text. It has a tap gesture on this resource.url that opens up the specified URL in a browser. And it shows a text field with dynamic notes that are automatically synchronized based on this editing notes state. So this view has its own local state just for the notes that you're editing. When that view appears, it sets the editing note based on what it received as an immutable default note value. When that view disappears, it calls that update function that was passed in. And the responsibility for updating the environment, updating the mutable state happens at the parent level, happens in the function. It happens within the function that's called here, but that function was passed in by the resource view, it's not managed by the resource detail view. Quick example of this keyboard responsive view. The keyboard responsive view it's adapted from a few different examples. This is one of the pain points where there doesn't seem to be a single official way to do this, a single official way to manage these kinds of things. So this is one of the areas where the Swift community is experimenting. Expect we'll have more, that'll stabilize. Or it's starting to become a bit stable for very common interactions. But here we have a Swift structure. It's a SwiftUI view, contains the view attribute. It has internal state for the keyboard height, and it uses the classic UIKit or Foundation notification center. It uses the publisher on the notification center to subscribe to the keyboard will show notification. It defines a function to be invoked on every event. So this map is, in the context of this, this functional reactive function, is defining an inbound function or a function handler for every event. So basically when the notification center publishes the keyboard will show notification, the notification is received, the keyboard size is inspected, and if it's able to get a keyboard size, it returns that keyboard size. We have a similar one for when the keyboard hides. We set the keyboard height to 0. So keyboard will hide, keyboard will show. So when the keyboard is hidden, we don't really care about the inputs or the notification. What that means as far as this keyboard view is that as far as the keyboard view is concerned, when the keyboard is hidden, the height of the keyboard will be 0. So we've defined these subscriptions to Notification Center. We have this, we define the view that adds in the keyboard height as a padding attribute. And whenever this keyboard responsive view receives a notification from the keyboard will show or the keyboard will hide, in either case, it processes that final event, that final value, receives the float for the height and updates the keyboard height to that value. And that keyboard height is a padding attribute on the contained view. So this will make most sense as a quick example. So I have, in another window, I have QuickTime recording my phone. So I can, this is using the default dark mode because the phone is in dark mode. So go here to a resource, because we can filter and some warnings. We go into the Swift programming language book. Can tap on this and go to directly to the link. Can go back to the app, and here there's a notes attribute, and you can see, and this is very rough in the sense of automatically resizing or setting the padding on the view. So we see the data, the views collapse a bit. When we hide the keyboard, it eases back. All the animations that you see in the app are some of the standard defaults for SwiftUI. Certainly want changes, probably want to make adjustments there, but those are the default animations. So we have here some keyboard behavior. I'm going to add a test note. So I have here a note that I've added. I'm going to hide the keyboard. You see the padding go back down, so the keyboard, the view goes back to its previous display. Go back to the list, and when I return to the detail view, because it was passing in the value from the environment object and had updated the environment object, we see that value persist. And we see it persist even if we go back, and so we've destroyed those views. We go back to the beginning of the app, recreate these screens, because we persisted to environment, that environment value remains present. So very brief example of that. For UIKit or broader iOS notifications, the approach I'm seeing most often, but it is something that is still emerging. The approach I'm seeing most often is to define some containing structure that subscribes to the notification center, has those notifications mutate state, and has that state pass through or flow through to inputs to declarative views. So what that brings us then in this example is a collection of UI tests that ultimately goes here to this resource details screen, opens the header, or verifies the static content, and then finds the text field for notes, for entering notes. And we have here this text field accessible through the resource detail.notes identifier. And the resource details notes text field we get, and then inspect a couple of things here. So there's a question earlier about why are we looking for identifiers instead of the actual text on the views. The big reason is internationalization. That's the main reason. The main reason is that static text variables for copy in the application don't lend themselves well to internationalization. And so if you ever need to add a second language to the app, it's much easier if you've been building it in an internationalized way from the beginning. A second reason, even if you're just using a single language, is if you define a struct that can contain the copy displayed to users, being able to decouple the concrete text and concrete images or values shown from the structure in which they appear is valuable because it allows us to separate design, it also separate some of the design of the communication from the design of the interaction and of the system. But here we do care about the actual values. So we have a placeholder text and we use the value for key. We have to force unwrap an optional value from a dictionary to get a placeholder value. This is weird, or it's not very obvious, but we use the ability to look up a value for a key to get the placeholder value from this text field, and then we can assert that that placeholder text is equal to notes, and also the quirk of SwiftUI, the placeholder value shows up as the actual value until you make changes. Also a bit of a counterintuitive thing. So we confirm those two things, then tap on the field, type some text, and then hide the keyboard by pressing the return button. Go back to the previous screen, tap on that same resource row again, and then confirm that the notes we've entered are still there after we go back. Again, this is assuming a zero knowledge UI test that's simply tapping on things on screen, looking at what's on screen, going back, returning to the screen, and confirming that the same visuals are there. So one extremely valuable tool for this is if you are running if you're trying to figure out ways to get at more detail in the view to understand what's going on in order to define an effective test, you can use the debugger and run the print object helper, which has been around for a long time, but it is especially useful here because you get something that, so right now this is running through the initial screens. We have a breakpoint here before we get to this placeholder text lookup. We can see here by the fact that it's taken 20 plus seconds or more, this does tend to be a slow style of testing, but certainly worth running in a build for a CI. So here we're paused, and if we run this, here, we can now print object, and we have a reference to this resource detail notes text field. And we can use the autocompletion. So we're going to print out that object. So this is starting to look like something you see in a web project. So we have an element subtree, we have the text field, and we have an identifier. And here's the identifier we're using. And there is a placeholder value of notes that we can access. And we can see here a printout of the view hierarchy, from the application down that gets to that view. And here we have more detail. We have the identifier, the placeholder value, and the value. If there were more attributes, we'd see those as well. So for identifying how to get at something to make assertions about it, it almost sounds like an anti-feature, but this debugger output is useful for that in the absence of better tooling to inspect that without having to resort to the debugger. I'll leave it at that. So what we have here is I hope this has been useful. Basically, we have here a summary of one way to approach a collection of interactive tests, walking through and exercising, in this case, every single feature of the iOS application in a way that uses the element queries available in XCUI tests to define what should be there on the application in a way that's a bit abstracted away from the actual content, but would provide alerting to any regressions in the structure of the app UI. I'm going to go here into the summary and just add my email as well. I'm planning to follow up with sharing some access to the sample project, continue to expand out some things as a useful, as I hope will be a useful illustration of various concepts. Thank you all for taking the time. Thank you for your questions. I see some recommended links. Thank you for sharing those. Look forward to exploring those. I think test-driven iOS is possible. You have to change your test driving iOS is going to be different. Than test driving a web application or test driving a dynamic language that lends itself particularly well to testing. So for these kinds of UI tests, one could write the test first. One could write the test alongside the interaction. I think the enforced separation of mutable state from view rendering and the flexibility now, as we had one example, flexibility now to have first-party native visual controls that allow passing functions around instead of references to selectors with UIKit. I think that gives us much more flexibility, and I'm excited to see what we and what you all build with this. We'll share a copy of the code. Feel free to reach out with any questions or ideas on as you're exploring SwiftUI and iOS changes. Thank you very much, and we'll call it a day.